Welcome to Cosplay Engineering. I'm ACraftyHobbit, and this month we're talking about adding series LEDs to your cosplay and programming them for various effects. Today I will be focused on programmable series LEDs, or specifically programmable Christmas lights. What this means is that each light is individually addressable. I will be working today with the WS2811 RGB LED pixel lights. As always, I will teach you how to wire up the electronics, break down the code to program various effects, and then assemble it all into an actual prop. Let's get started. With the release of the Final Fantasy VII Remake, I thought it would be fun to make a light-up prop connected to the series. Originally, I designed materia balls to sit inside a chest. However, I just couldn't get excited by this project, so I scrapped it and went back to the game to find something else. I decided to do the lantern held by a Tonberry, which allowed me to explore new modeling tricks like screw threads for the base, lofting to create the glass's unique shape and decorations, and draft to create the lid. Now on to the wiring. I actually ran into some issues when trying to wire up these lights. I eventually figured out that it was the female connector piece that was faulty, so I cut it off and just used the wires. I got out my Ardiuno and a breadboard. For these particular lights, the blue wire is to ground, the white wire is data in, so that went to pin number 6, and finally the red-orange wire is power, so that went to power. As always, I wired up the button to allow me to control the lights with it. Again, it needs power, a 10K resistor to ground, and a wire back to pin number 2 on the board. Here is the wiring diagram. Moving into the code, I used the Adafruit NeoPixel library in order to work with these lights. At the top, I included the library, defined the button pin number 2, the pixel pin number 6, and how many lights I was working with. This line defines the strip object. As with my other sketches, I created variables to track the button state and mode to be able to control the lights at the push of the button. The setup function initializes the button and the light strip. Now into the loop. It first reads the state of the button, then after a bit of a delay, it checks it again to make sure that the button was actually pressed and it wasn't noise. Next, increase mode. If mode is greater than 1, return mode to 0. Then it looks at mode within the switch case. If mode is equal to 0, the strip should be set to off. If mode is equal to 1, it calls the function setColor, which takes in a color and a delay time. It applies that color to each of the lights with the bit of delay, allowing each light to turn on one by one. This can be set to any color. More cases can be added to change to different colors when the button is pressed. While delay is used a lot in code examples for lights, it has its problems. Notice when I hit the button, the light doesn't always turn off right away. This is caused by the delay. Because the code is operating line by line, it takes some time before the Arduino will read the button again. This can cause problems with more complicated light effects and sequencing through different button presses, because it won't stop or turn off until it completes a full cycle. To fix this, on my sketches, I removed the delay and added a counter variable and a max count variable. The max count is the number that can now be adjusted to control the speed something happens. The key here is to make sure that the Arduino gets through the entire loop as quickly as possible. The ability to address each light gives them a lot more flexibility to create movement with the light by simply turning some of them on and some of them off. I'm now going to make the light chase itself down the strand. I took the basic framework from the previous sketch, this time adding counter and max count, so the delay is not needed. Along with it, I created a variable for location. Nothing changed in the setup or the first part of the loop. The only change was case 1. This time, when mode is equal to 1, the counter variable is increased. It then checks if that counter is equal to max count. If it is, run the function light chase, which takes in a color and a location number. In light chase, the strip is first cleared, everything is set to 0. It then counts up from the location number to the end of the strip in steps of 3. It then lights up the particular lights with that color on the strip. The counter is then reset to 0 and the location is increased. If the location is equal to 3, return it to 0. Finally, I'm going to combine it all together to show what these lights can really do, which is both creating multiple colors and movement. Everything is the same as before, the only change is case 1. When mode is equal to 1, increase the counter. If the counter is equal to max count, use strip.setPixelColor. Select a random light on the strand and apply a random value in RGB between the values of 0 and 255. Then update the strip and set the counter back to 0. It will continue to do this until the button is pressed again and the mode is changed. Moving from code to soldering. I start by soldering 3 wires into ground, 1 for the battery, 1 for the button, and 1 for the lights. I attach a 10K resistor to one of the ground wires for the button. I add a wire to VIN for the battery, 2 wires into 5 volt, which will power both the button and the light. I then solder a wire into pin number 2 for the button and pin number 6 for the lights. The wires for the lights actually go to a male connector. I attached a new female connector to the lights, making sure to connect to the correct wires. In this case, red is going to red-orange, white is going to blue, and green to white. I next solder a wire to the button, dividing it for the pin wire and the ground wire. I connect a wire for power. I then connect the button to the board. I connect a battery to make sure it all works. Here is the soldering diagram. If you're using Adafruit's NeoPixel library, but the lights of your project aren't coming out correctly, check the line Adafruit_NeoPixel strip. The pixel flag declared there might be different from what you need in order to get your lights to work. Each manufacturer does wiring differently. Make sure to read the specs on your lights so you know which wires connect where. The colors vary between them. Alligator clips are a nice to have supply that can give you another non-permanent solution to connect between wires. Thanks for watching this episode of Cosplay Engineering. Next month we will be moving to a new electronic LED strips, which are amazing for swords. I'm also going to be changing up my release schedule, so it will now premiere every second and fourth Thursday of the month. To see what I'm up to in between episodes, make sure to follow me on my social medias. Likes are always appreciated, and make sure you're subscribed to this channel and hit that bell. Stay safe, stay home, wash your hands. Bye!